Hello, and welcome to STEM at Home. I'm Deborah from Prince George's County Memorial Library System, and I'm very glad you're here. We're going to conduct 3 simple but interesting experiments today using common household items. All of these ideas come from the book Junk Drawer Chemistry by Bobby Mercer. This book and several similar titles are available in Overdrive, which is one of the library's online resources that includes ebooks. Now, the common household items that we're going to use are in the following list. So let's take a look at the materials list. And these are all the materials we'll need for all 3 experiments. For the first experiment, we're going to use a small bowl, a little water in the bowl, pepper or any spice that doesn't dissolve in water like thyme or rosemary, a toothpick, and liquid soap. I'm going to use liquid dishwashing soap, but any liquid soap will do. For the second experiment, we're going to use clear plastic tape, like the kind you would use to wrap a present, and a marker, though the marker is optional. The last experiment requires adult supervision. We're going to use a measuring cup, vinegar, baking soda, a tealight candle, and a match. I hear my dog in the background. Okay, let's go try our first experiment from Junk Drawer Chemistry. Okay, now we are in the kitchen for our first experiment, which we are calling scared pepper. I have our materials here. A small bowl with a little water in it. Some pepper, which is my choice of non-water soluble condiment. 1 toothpick that's rolled over here. We've got our toothpick. And just a touch of liquid soap. I'm using just dishwashing soap. Any liquid soap will work. First, let's put our pepper in the water. And because the pepper is hydrophobic, which means it will not dissolve in water, we can see the pepper on the water. We're going to next take our toothpick and poke it into the water and see what happens. No apparent change, nothing dramatic there. Now let's try it. We're going to dip the toothpick into our liquid soap. Don't need a lot of soap, just a touch will do. And we are going to now dip the toothpick that has been dipped in the liquid soap into the water with the pepper. And let's see if there's anything different that happens. Okay. Yes, there is a dramatic scattering of the pepper away from the toothpick. So what's going on here? Is the pepper scared of the toothpick? Or is something else happening in there? Okay. Let's take a closer look at our first experiment. As we see, the pepper floats on top of the water. It's actually floating because the water's surface tension keeps it up there. The surface tension is caused by the water molecules being attracted to one another. Each water molecule forms a bond with the water molecules around it. When we poked the plain toothpick with no soap into the water, nothing really happens. However, when we put some soap on the toothpick, we see something dramatic. The movement of the pepper has nothing to do with the pepper itself. The pepper just shows us the reaction when the soap comes into contact with the water. Soap disrupts surface tension. When we add soap to water, the water molecules move away from the soap because they want to maintain their molecular bonds. And the pepper we had scattered away with the water. So when we wash our hands with soap, which I hope we're doing regularly right now, and using good technique, getting the palms, the backs of our hands and our fingers, in between fingers. Anyway, the soap loosens the surface tension so that dirt and germs can flow away in the water better. And soap is also designed to attract some of a lot of that dirt and germ as well. So that washes away too. That helps, and that's important. Okay, let's try our second experiment. For our second experiment, we have our tape and our optional marker. And we're here at my kitchen counter. You can use, we need some surface used for mica or plastic or metal. Do not use a wood surface. And I will repeat, do not perform this experiment on a wood surface. I learned the hard way, and now I have to restain a table. To start, we're going to tear off about 8 inches or a foot of tape, maybe a little more than that. And we're going to make a little tab or handle at the end by folding the tape over on itself to make like a little non-sticky end. Okay. And then we're going to put the tape, press it down with the handle off the ledge toward you. And I'm going to use the marker to write on the tape just so we can see it there. We're going to do the second thing, the same thing with the second piece of tape. Got my tape, going to make a little handle. Not doing too well with this tape. And press that down. That one's a little bit longer. I'll take off a little bit. Okay. And we can write on that one too. Press them both on the... Okay.
All right.
Now we are ready to lift the pieces of tape off of the counter, and let's see what happens. I'm going to hold them close to each other. Okay. And you can see when I bring them together, they sort of push away from each other. Okay. Now we're going to do the same thing, but I'm this time going to put, you can get a new piece of tape. I'm going to try to reuse this tape. I'm pressing one piece of tape down, and I'm going to press the second piece of tape directly on top of the first piece of tape and press that in. Now we're ready to lift the tape again, both pieces. But what, whoops, now it's tracking to me. Now the tape, I don't know if you can see this, but the tape is now, they're attracted. The pieces of tape are attracted to each other. It's hard to keep them apart. So what's different about putting them next to each other or on top of each other? Let's see that again and talk about what's happening to the pieces of tape. This experiment demonstrates the electric charges of the atoms in the pieces of tape. Atoms are made up of 3 parts: protons, neutrons, and electrons. Protons are positive, neutrons are neutral, and electrons are negative. And all atoms start out as neutral, neither negatively nor positively charged. However, electrons can move from atom to atom, creating either a positive or negative charge in the atom that has lost or gained an electron. Like charges, for example, 2 positive charged objects, will repel each other. Remember that the pieces of tape in the first part of our experiment repelled each other. So we know those pieces of tape had the same kind of charge, either positive or negative. Unlike charges attract each other, like the pieces of tape in the second part of our experiment. In the first part of the experiment, the tape gained one type of charge and the counter gained another type. So the pieces of tape had the same kind of charge and repelled each other. In the second part of the experiment, one piece of tape gained a charge from the other piece of tape. Remember, they were right on top of each other. So they had opposite charges and were attracted to each other. All right, one more to go. Let's try our final experiment. Okay, in our third and final experiment, we're going to attempt to pour a gas. We're not pouring a liquid, we're going to pour a gas. I have our materials here, excuse me. A measuring cup, vinegar. We use a lot of vinegar in this house, so I have a very large bottle of vinegar, baking soda, and a tea light and matches to light the tea light. First, we're going to add about a quarter cup of baking soda to the measuring cup. And I've got a large measuring cup here because I have a hard time seeing the numbers on my other measuring cup. So this is a 2-cup measuring cup, but I'm going to put in about a quarter cup. It doesn't have to be perfect, but I'll get that in there. Okay. All right. Now we're going to put in about a quarter cup of vinegar into the measuring cup with the baking soda. Let's see what happens. We're doing this slowly. I did that slowly. Should have emphasized that because we don't want to lose the gas that's being created. Okay. Now with an adult, we will light our tea light candle. So we have our flame. And here's the moment. I'm going to carefully, let's give this a go, pour the gas out, moving the spout. We're going to do this slowly. Aha, it worked! I did not pour the liquid, but I poured the gas out and it extinguished our candle. All right. Let's look at our final experiment one more time. We see that when we combine baking soda and vinegar, a chemical reaction occurs. The combination creates a gas, carbon dioxide. The carbon dioxide gas stays in our measuring cup because it is denser than air. When we tip our measuring cup, the denser gas moves down around our candle. We know that fire needs oxygen to burn. The carbon dioxide, that gas, blocks the oxygen from getting to the candle, so the flame goes out. Pretty cool. Again, these experiments come from Junk Drawer Chemistry by Bobby Mercer, published by Chicago Review Press. It includes 47 other experiments using common household items. You can check it out on Overdrive, as well as other titles that include science experiments. Thank you to Mark for filming the experiments, and thank you to all of you for joining us for today's STEM at Home. We look forward to seeing you next time. Be well. Those are all the materials we'll be using for all 3 experiments from Junk Drawer Chemistry. So let's go conduct the first experiment.
Sorry.
What?
You just said Junk Drawer Chemistry. Junk. You said drunk instead of junk.
I did?
Yes.
Okay, so we got to do that again. Yeah. Okay, so first let's add the pepper to the water. Ooh, got a little pepper on Sorry about that. It's getting all over the cutting board as opposed to the... Guess I need to use a different pepper mill. Okay, let's start over.
Did you use that one before?
No, I used the other one. Sorry.